Morning, everyone. Today is 10.3, Tangents to a Circle. Let's begin. There are two key ideas in 10.3. The first is the tangent to a circle, and what that actually means. A tangent to a circle is perpendicular to the radius at the point of tangency. Okay, let's read the second one and then we'll explain. A chord drawn tangent to the point of tangency contains the circle and is a diameter. So here's what this means. If you have a circle, good looking circle there, a tangent to the circle is a line that touches the circle at exactly one point. So if we look at this line over here, this line touches the circle at only one point, right there. Okay, that is called the point of tangency. This is a tangent line. That point where it touches is the point of tangency. Okay. Again, I know the words are different than what you're used to, but it's important to have the proper phrasing. So once we understand that this is the point of tangency, here's the next step. If we have a line that comes from the center of the circle, and hits from the center of the circle to the point of tangency, this becomes a 90-degree angle right there. Okay? So any line from the center of the circle to the point of tangency forms 90-degree angles. Okay? That will be very important as we go forward. Let's look at the first example. Example 1 says to determine the angle measures in a circle with a tangent line. Okay? In the diagram, AB, so this line right here, is tangent to the circle at point D. So there's the point of tangency, right at point D. BE also contains the diameter FE. So F to E is the diameter because it goes through the center. And ABE is 50 degrees. So we know this is 50 degrees. We have to answer what is BDC, what is DCE, what type of triangle is CDE, what type of triangle is DEC. We'll go through each of them one at a time. First off, the measure of BDC. So this angle right here. Well, this is a tangent line with the point of tangency right at point D. This line C comes down and touches this line right at the point of tangency. So this forms a 90-degree angle. So the answer to what is the measure of BDC is 90 degrees. Okay. Next, we're asked about what is the measure of the central angle DCE. Okay, well, before we can do that, we're going to have to answer one other question first. The first thing is, inside a triangle has to add up to 180 degrees. So anytime you know two angles in a triangle, you can figure out the third one. In this triangle right here, we know this angle's 90 and this angle's 50, so the remainder has to add up to 180. So 180 minus 90 minus 50 will tell us that this angle here is 40 degrees. Next step, to get the measure of this central angle DCE, we have to remember that a straight line is also 180 degrees. So if a straight line is 180, this piece right here that we have is 40 degrees. 180 minus 40 will tell us that this part right here is 140 degrees. Okay, so it took a few steps to get there, but that's the process for how you solve that. So B is 140. Next, this type of triangle that it's asking about right here is what's called an isosceles triangle because it is formed by two radii that are equal. Anytime you have two sides in a triangle that are equal, it's called an isosceles triangle. And what we know about isosceles triangles is that these two sides are equal and the two base angles are equal. So if the triangle has to add up to 180, we go 180 minus 140 is 40 degrees. And those 40 degrees need to be split evenly between those two angles. So we divide it by 2. So this is 20 and this is 20 over here as well. Okay? 20 and 20. We're out of time for part 1. I suggest watching this once more, and then I will put part 2 up momentarily.